Welcome to the Aimbot tutorial. By the end of this tutorial you're going to have a fully functional aimbot and you will understand how it works. I structured this tutorial in 4 sections. First I'm going to show you what we are actually creating in this tutorial. Then I will try to make you understand what we are trying to calculate to get this aimbot working. Then we do the calculations and finally we jump into Visual Studio and code the aimbot. Okay, so let me start by showing you the result. When I inject this DLL here, it's an internal aimbot. You can see it aims nicely at the closest enemy to us. When I kill him, it aims at the next one, and I can go on and kill all of them. Alright, so our goal when creating an aimbot is to always look at the enemy's head, and we can calculate this angle we have to look at using trigonometry. And we're going to need our view position and the enemy's head position. And as you guys probably remember from school, we're going to need right-angled triangles to do some, to use our trigonometric functions, or however that's called. But I can't see any triangles here right now. So to make this easier for you, I added some layers. Maybe those will help finding these triangles. So this corner right here is my view position. And I've also added the straight line from our view position to the enemy head, the blue one right here, and from our head position to the enemy feet. And I can see some triangles right now. Can you see the triangles? This is like a Blue's Clues episode by now. Alright, so if I'm standing here and I want to aim at this blue line, I have 2 angles I have to calculate. One is the height I have to aim at, also called pitch, which basically is just this angle between this red and blue line right here. If I stand here, I'm currently looking at the red one, I just need to aim up exactly this angle towards the blue line. And so now we got our height perfect, but we still could be off to the right or left side. And to get this angle, we'll have to spot another right-angled triangle. And there are many more, but I'm going to use this one. That's this white line, the right angle here, this white line, and this red one. So if we calculate that angle too, we can aim at the correct height, like this maybe, and then even aim at the correct jaw, which is left to right basically, and then we're exactly at the enemy's head. There are a few things we have to take into consideration when doing our aimbot calculation. First of all, we have to determine if our view angles are saved in radians or in degrees. And I know there are still a lot of people getting confused by it, but it's just 2 units for the same thing. So with radians, instead of 1 full turn being 360 degrees, it's just the distance traveled along the outside of the circle. Specifically of a unit circle, that's a circle with a radius of 1, and therefore 1 full turn will be equal to 2 times pi. And that's why we can easily convert between degrees and angles. So when we have degrees, we just have to multiply our value by 180 divided by pi. And if we have radians and want to convert to degrees, we just have to multiply by pi divided by 180. So absolutely no reason to get freaked out by radians or degrees. Very easy thing. Okay, so let's jump right into the game and see which unit our view angles are in. So when I look all the way down, I've added my view angles here in Cheat Engine. You can see that the pitch is equal to 89. And when I look all the way up, you can see my pitch is equal to minus 89. And when I look around myself to the left, you can see that my jaw goes from minus 180 to 0 and then to plus 180 in the end. Okay, so yeah, what unit are our view angles in? Definitely degrees, because as you know, a full circle is going to be 2 times pi when we have radians. And we have values like 180, which would be a half turn if the unit is degrees. So it's very safe to say that the engine saves our view angles in degrees. Yeah, so let's take some notes about the information we found so far. We know our pitch is in the interval between -89 and 89. We know our jaw is from -180 to 180, and we know its degrees. The next thing we have to pay attention to is the parameters and return values of the trigonometric functions we're going to use. So for example, if we were going to use the sine function, we can see here that it is expecting an angle expressed in radians and will return the sine of the angle in radians. But we actually need the angle itself, so we can aim at this angle and not the sine of this angle. And therefore we are going to use the inverse function of the sine, which is a sine. And you can see here it's expecting a value between -1 and 1, and will return the angle in radians in the interval between -pi divided by 2 and +pi divided by 2. So pi divided by 2 is equal to 90 degrees. As you can see here, they were also nice enough to give us the formula to convert between degrees and radians. And when you see this interval, like between -90 degrees and +90 degrees, I think this would be a very good match to calculate our pitch, because it's very close to the interval the game uses to represent our view angles, and it's just 89 because in CSGO you just barely can't look all the way up, or barely can't look all the way down. We will make sure later that we never set our view angles to exactly 90 degrees or -90 degrees, because or pitch specifically, because that's a very easy check for an anti-cheat, and in fact will get you instantly banned in CSGO. Okay, yeah, so what we got now is we know what we want to use to calculate our pitch. We want to try and use the a sine. Now we need another trigonometric function to calculate our jaw. So let's have a look at cosine. Again, using the inverse function here. And let's see what this one returns. It returns in the range of 0 and pi. So between 0 degrees and 180 degrees. Now that doesn't match our jaw too well. So I will have a look at the tangent function. So atan C++. And we can see this one returns minus pi half and divided by 2 and pi divided by 2. So this is again in +90 and -90. That is also not really what we're looking for. And but there's another function atan2. So let's have a look at this one. And this will return on this one's return value will be in the interval between -pi and pi, which is exactly -180 degree and 180 degree. So we're definitely going to use this one. And the main difference between atan2 and regular atan is that atan2 takes 2 parameters. And what this does for us is it solves the problem in different quadrants. So when you have coordinate system quadrants, you can see here, for example, there are 4 quadrants in a coordinate system. And if we were to use regular atan, we have to catch every case, see in which quadrant we end up, and then do some calculation based on that. But atan2 is going to do everything for us, and we just have to take the returned value in radians, convert it back to degrees, and we're good to go. Alright, so now we have our 2 functions we're going to use to calculate our view angles, and we are ready to jump into Visual Studio and do the actual Aimbot. So let's start with a fresh project here. As this is not my first take, I will have to come up with a creative name. I don't know. Yeah, first I'm going to change the project's configuration type, because this is an internal project. We're going to make this a DLL. Oh, I only did it for release. Also have to do it for debug now. Alright, yeah, I will start by just copy and pasting some boilerplate code. All this code does is defining a main entry, creating a thread, which will then spawn a debug console, and then in an infinity loop just call this a run function until we press delete. Then it will unload the hack without crashing the game. I'm calling this run method. It doesn't exist though, so I will just start by creating it, run, and then include it here. Cool, so now this run method is getting called in an infinity loop, and yeah, let's start by adding in some offsets for the game so we can actually read our position and enemy position and our view angles. I'm going to name this offsets. I will use haste dumper, which will automatically use signatures to dump all the required classes. Right, this is haste dumper. I got CSGO running still. So now what I can do is just execute it, and it will generate a nice header file for me here, which I can just open, copy and paste my offsets into here. So now I got lots of offsets already. Yeah, if you do it on a different game, of course, you will have to maybe reverse the offsets yourself or find them elsewhere. Okay, so let's start by creating our local player class. Again, I'm going to copy this just so it's going to be a little faster. Local player. Yeah, so I just created this class which has a static member local player, because there will be only one local player. Made the constructor private, so you can't create any more local player objects, but we'll have to use this this method here to get an instance. Right, and then I also have code to get my own origin and my view offset, my health, my team, aim at the target enemy, and to get the distance so we can aim at the closest enemy to us. The more interesting part now is the implementation of this class. So let me just add a source file here. Local player, include local player. I just like to copy and paste this over so I know what I'm going to implement. Alright, so let's start with the get function. Local player pointer, local player gets. Alright, so yeah, what I will be doing here is use the haste dumper offsets to get the game's instance of my local player. Okay. Yeah. So there's nothing too fancy going on here. Get module handle will return the base address of the current module. Get module handle. If I pass null in there, it will be the module that this DLL is executed in. So let me include Windows so I can actually call that. Cool. If you are familiar with CSGO, you know the local player is actually not in the main module like in csgo.exe, but in client panorama.dll. Panorama.dll. Okay. Also, I made this static so it doesn't get it's only ever initialized once when the method first is called, and not every time I call get, because that's pretty CPU intensive. Alright, so now we got the client module address. Let's get the local player from it. Local player. Cast this into the local player pointer. Get the client module, and then use the offsets I just added. So I have to include them, of course. Offset, and then use haze dumper. I think it's in signatures, and then local player. Alright, cool. So if you have any questions regarding local player, entity list, or anything CSGO specific, please consider the other tutorials on these topics. This one is more about the math behind it, and I'm not going to explain how to find these values in CSGO or any other game. Alright, so finally we just have to return this value, and we're done with our get method. Cool. For the other methods, I'm just going to copy and paste them straight away from the example project I made for this tutorial, because there's nothing special going on. Let's take origin for an example. It will just use the this pointer, which is equal to the local player we returned here. And then add the offset that we got from the haze dumper, and then return a pointer to that location. Okay. I think that's all we need for now. So let's start with adding other players like our enemy. Also, I made another class for local player, even though it's also a player, because I wanted to have functions like this AimAt function as a member function that I wouldn't be able to use on regular players. And I also just like to split that. Okay, so I add a player header file. Again, just copy and paste these things over. It's basically the same stuff as with the local player, with the difference that I here also added a function to get the maximum players, so I can iterate a loop, and then a get player function that will return me the player of an index I can specify here. Okay, yeah, the implementation of this class again is not very special. I will just go ahead and fully copy and paste it into here. Okay, I need to add a vector3 class. All right, header file vector3. Also paste it over here. It's just a class that holds 3 variables, because positions, of course, in CSGO are 3-dimensional, and will just allow me to have the location stored in a separate type. You can also always use the source SDK or some hack bases. They have classes for all these things defined already. Okay, get player is just getting me the player from the entity list. There's a very recent tutorial on the entity list in CSGO on this channel. So if you have any questions regarding this, please watch that tutorial. I will also link to this stuff in the description of this tutorial. Max players will just return the total amount of players. The other stuff is the same as in local player. And I've also added in here a get bone position, which will return the exact position of the head of the player. Why is he mad? Get bone position. Vector3, incomplete types, not allowed. Class vector3 is here. Player, we include vector3. Why are you mad? Returns incomplete type. Because it doesn't know the size of it here. Alright, I will just return a pointer to it then. Yeah, that's just some C++ specific stuff that I'm not going to go into great detail. This is annoying, of course, now. I will just make this static again. Return. Alright, let's hope my quick fix here didn't mess everything up. Let's see if it... Wow, it compiles. I'm kind of surprised it did compile right there. Okay, what do we have left to do? We don't have these functions defined yet. And I'm just going to copy them straight over. What are we missing? Oh no, we got get origin, we got get view offset, health team, get. Oh, we are missing AimAt and get distance. So yeah, AimAt is the most important function of the tutorial, of course. I will just copy and paste the get distance function over. And he is mad yet again. Oh, because I didn't include vector 3 here. That makes sense, at least. Vector 3. Nice. And we need math to do square root right there. Ha! Alright, now we're compiling again. So get distance will just get the 3-dimensional distance in... yeah, we'll just get the distance between us and a point we specify in 3D space. It's just plain math, nothing CSGO specific or anything. Alright. And let's see what we're going to put in our heck method, in our run method here. So first thing we're going to need is a way to get the enemy that is closest to us. And we will have to write a function for that. Now, to not make this tutorial longer than it already is, I'm just going to paste this function straight in. It's pretty self-explanatory, so if you have any trouble with it, just pause the video here and have a look at it. Also, the full code will be available, so no worries. Okay, so if we found closest enemy, what we want to do is get our local player and aim at that closest enemy. So we get closest enemy, get bone position 8. In CSGO, this will return the position of the head bone. Yeah, and that's all we have to do. But we haven't defined this function, so that's the next thing we have to do. Let's jump in here. Alright, so this is where all the knowledge we gained from the previous parts of the tutorial will yield us good results. Now that we got all the values that we need to do our calculations, let's jump back into CSGO and spawn the triangles. And we agreed that the first angle we want to calculate is between this red and this blue line, so we aim at the correct height. Since we want to calculate this angle, this makes this red line the adjacent, this white one right here the opposite, and of course the blue one the hypotenuse. Also, we noted that we want to calculate this using the sine function. So let's check out what the sine function needs. The sine function uses the opposite and the hypotenuse. So we need this length right here and this length right here to calculate this angle. Getting this length, of course, is easy because it's just the difference in height between our head and the enemy head. Yeah, which is just this white line here, basically. And then we have to get the length of this blue line because that's the hypotenuse. And that's the first thing we're going to do, is just get this length. So yeah, the first thing we have to do for that is actually, oops, I copy and pasted the wrong line, is to get the delta vector, which is exactly this blue line. And you get a vector between two other vectors by subtracting your source vector from the target vector. And so we are subtracting our head position from the enemy's head position. And that's exactly what we're doing here to get this blue line, which is the vector. And then we use this formula, this distance formula again in 3D space to get the length of this blue line, which is our hypotenuse. So now that we do have the length of it, we can calculate the pitch using the sine of delta vec dot z, which is exactly the height difference of our head and the enemy head, and divide that by delta vector length, which is the length of the hypotenuse. I forgot an equal sign there. Okay, and then of course, since we will get back radians, and CSGO, as we have determined, uses degrees, we have to convert it back to degrees before we can use it to set our angles. And that's exactly what we're doing here. Pi is not defined. So let's define pi real quick. I'm just gonna do a double here, and name it pi, and then set it to pi value. Yeah, and I think if we set the view angle, our view angles to this pitch angle, we should see something in game. We are hoping that we have the correct height at least. So I'm just going to inject this DLL. All right, and I can't move upwards or downwards, but we see we're definitely not at the head height. What we do notice though is as we get higher, we aim above the enemy head if we are higher than him. And if we are lower, we aim below his head. And that is because we have to, we're currently calculating a sine, but we have to prefix it with a minus. And that is because our view angles, as you can see if I attach cheat engine in CSGO, yes, in this case, our pitch, so the first line here will actually decrease if we go higher. So if we go all the way up, it's minus 89. And if we go all the way down, it's 89. So that's why we need the minus there. I knew this was going to happen in this case, but I just wanted for you guys to know that when you're testing your calculations in a game and you see some side effects like this, you just know sometimes you will be off by 90 degrees or 180 degrees, or you will have to prefix it with a minus. And I don't really think it's worth to go and think about all this stuff beforehand. It's more important that your calculations are mathematically correct, and you then can deal with game-specific stuff as you go. Okay, so now that I've added the minus, I will quickly recompile it and inject it again. And you can now see that I'm always aiming at the correct height. To calculate the jaw, let me just inject my laser shell again. Yeah, we need to calculate this angle here where we're looking. And yeah, we said earlier that we were going to use 8 and 2 because the return result is exactly the range that CSGO uses, so it's a perfect fit. So let's check what tangent takes. Alright, tangent takes opposite and adjacent. So let's find a triangle to get this angle where we have those two values. So if we stand here and for example we want to calc this angle here between this white line and this red line, we have this white line as our adjacent and this white line as our opposite. So that's exactly what we need yeah, to calculate this angle. So what we can do here is float jaw is equal to 8 and 2. We said we're going to use 8 and 2 because it's better than 8 and because we don't have to deal with different quadrants. And we're going to use delta vec dot y and delta vec dot z. Again, that's just these two lines. As you can see, the difference in one direction is exactly the white line above me now, like this one. Oh, let me spawn it again. Is this one, and the difference in the other direction is this white line, and it's exactly the triangle we want to calculate, so we can just use this. Then of course we will also have to convert the results in radians back to degrees before we can make use of it. And then also set our view angles accordingly. Y equals to jaw, and then recompile, inject it into the game, and perfect fit. We're exactly aiming at the enemy head, and yeah, we now can shoot him, and yeah, there you go. Now, one last thing I want to mention so you don't get instantly banned is clamping angles. What this means is just making sure that the angles you calculate are valid in the game's engine. So as we determined, pitch in CSGO is between -89 and 89, and jaw is always between -180 and 180. And we will just make sure before setting the view angles that we calculate that we are within that range. So we are just going to check if pitch is greater or equal to -89 and pitch is smaller or equal 89. And then also if jaw is greater or equal to -180 and jaw is smaller or equal to 180. And only if that's the case, we're going to set our view angles. Now there are more sophisticated ways to do this, also to make sure that angles, for example, when talking about angles, 360 degrees is the same as 0 degrees and 720 degrees. And you never want to set, for example, 720 degrees to a game. So you would take the remainder only of 360 and stuff like this. But this is just the gist of it that I wanted to show you here. All right, and that concludes the tutorial. I really hope you learned something, and that you also can apply this knowledge to other games.